Hi, this session is on prime factorisation, and we'll be using what we know probably as factor trees to do this. Before we start, can I get you to put your homework in your planners if you haven't got this already, and you need to have it done by Friday. So questions 1 to 5 from 1D on page 20, and this will just cover what we're learning in this session if you haven't done it in class yet. Now, I want you to, before we start the session, can you do these 4 questions? Some of these relate to what we're doing now, especially question 4. So if you can't do question 4, then make sure you watch this session. So try these 4 questions first. Okay, the first question asked us to circle the numbers that are prime numbers. Okay, and with prime factorisation, that is a keyword in that title. So we know prime numbers are numbers that only have 2 factors, number 1 and the number itself. Okay, so only 2 factors, and factors we know are numbers that divide evenly into a number. And now we know every number also has a factor of 1. So if I was going to circle the prime numbers in this given here, 1 is not a prime number. So if you didn't know that, write that down. Okay, number 1 is not a prime number, so you shouldn't have circled 1. And that's because if I wanted to find factors of 1, okay, I know that 1 times 1 is 1 and nothing else. And unfortunately, 1 and 1 are the same number. Okay, there has to be 2 different factors. So that's why in maths, we don't consider 1 to be a prime number. Okay, so if you circled 1, you're actually wrong. 2 is a prime number because factors of 2, I know that there's 2 times 1 and nothing else. Okay, so that's 2 factors. And 2 is special. 2 is the only even prime number. So remember that. That means every other number has to be an odd number if it's going to be a prime number. So number 5, I think, is a prime number because I know I've got 1 times 5 or 5 times 1, and there's nothing else that I can think of. 2 factors, 5 and 1, and we're done. Number 6, straight away, I know 6 is not a prime number because it's even. If there's an even number, we know 2 will be a factor of that number. So 6 is not a prime number. 8, another even number, it can't be a prime number. Number 9. Now 9 is odd, so it may be a prime number, but let's see, what are factors of 9? So if I wanted to write down the factors of 9, this is how I started off. I put my 1 first and my 9 at the end, and see if anything else can fit in the middle. So I'll start with 2 next. Can 2 divide into 9 evenly? No. Can 3? Yes. 3 into 9 goes 3 times. Can 4? No. 5 can't. So I've passed halfway, so I'll stop there. And I can see 9 has 3 factors. And unfortunately, it's more than 2, so 9 is not a prime number. 13. So 13 is an odd number. Okay, and let me write down the factors of 13. So I know there's 1 and then 13 on the other end. Can anything else divide into 13? Can 2? No. 3? No. 4 can't. 5 can't. 6 can't. So that's pretty much halfway. So 13 is an odd number. It only has 2 factors, 1 and 13. And the last one we have is 15. I'll do 15 down here. Once again, write down the factors of 15. Let's see if it has more than 2. So start with your 1 and 15 on the other end, okay? And let's see. Can 2 divide into 15? No. Can 3? Yes, 3 can. So straight away, 15 is not a prime number. But the other factor of 15 is 5, because 3 times 5 is 15, okay? So you should have had those 3 numbers circled. Now, question 2 asks you to explain what an irrational number is. And so I'll put mine in dot points, and the two most important points are it's an infinite decimal. So that's a key word. Infinite means, we know it means it goes on forever. So an infinite decimal with no, another keyword, recurring pattern, okay? And then the other important point is irrational numbers, they cannot be turned into a fraction, or they can't be turned into fractions. That's another important point. And an example, you can give your own example. I'm just going to do a random one. So I'll just have, for example, 2 point, and we know there is no recurring pattern. So no numbers that repeat themselves, and there's no pattern. And it goes on forever. So I might go 1, 4, 5, 6, 8, 2, 7, and that's enough. And do those 3 dots indicating it goes on forever. And we can see there is no pattern. So you can do your own crazy decimal. Okay, the next question, number 3, what is the highest common factor of 12 and 24? Okay, so instead of trying to have a guess and think, oh, it might be 12 or it might be 5, we just write down all the factors of each number and compare them, okay? So factors of 12, so we'll start with 12 first. Always do this. You have 1 is always a factor of every number and put the number itself on the end, 12. So factors, we know there's a limited amount. And what can fit in between? So I know 1 divides into 12. Can 2? Yes. Can 3 divide into 12? Yes. 3 times 4 is 12. So I know 4 can. Can 5 divide it into 12? No. Can 6? Yes. And we've reached halfway. So that means I can stop because I know 7 can't and 8 can't because they've passed halfway. So 12 has quite a few factors, okay? It's got 1, 2, 3, 4, 5, 6 factors. Now let's see what the factors of 24 are. All right, so factors of 24, once again, I'll just squeeze it down here. Oh, I'll do it here. So we've got 1 and on the end 24. What can fit in between? So let's go. Can 2? Yes. Can 3? I know 3 times 8 is 24, so yes. Can 4? I know 4 times 6 is 24, so yes. 5 can't, but 6 can. 7 can't. I know 8 can. 9 can't. 10 can't. 11, but I know 12 can. I just squeeze it in, okay? Because I know 12 times 2 is 24. Now, 24 has quite a few factors. It's got 1, 2, 3, 4, 5, 6, 7, 8 factors, and that's a lot. Now, what we're going to do next is compare the factors. So what are common factors that we see? We can see 1 and 1 are the same, 2, 3, 4, 6, and 12, okay? So there are 1, 2, 3, 4, 5, 6 common factors between these two numbers, and that's quite a lot. But which one is the highest one? Highest common factor. The highest one is 12, okay? So we can say, therefore, 12 is the highest common factor of these two numbers. Okay, and number 4, now this one's really important with what we're going to do next. And it asks us to simplify this in index form. An index just means index numbers. We know that means powers, and that's the form we want to write it in. So it's not asking you to evaluate, to work out what is the actual answer, what's the number that this equals to. It's asking us to simplify, to make it more simple or smaller. And this is the easiest thing. You ready? All you're going to do is your first step, and we'll be using this skill when working with algebra. Write down the different numbers or bases you see. So I've got 2 there, times, there's a 4, there's a 5, there's a 6, and there's a 7. And don't forget to put times in between everything. So write down the bases once, okay? The different ones we see. So have I missed anything? No. And then your next step is count how many of those specific numbers do you see. So we've got, how many 2's are there? 1, 2, 3. So that means there's 2 to the power of 3, or 3 is the index number. Done. And you can cross it off once you've used it. 4, there's only one 4, so 4 can stay the same. We know there's an invisible 1 to power there. You can make it visible, but we know in maths it's invisible. 5, there's 1, 2, 5, so that's 5 to the power of 2, or 5 squared. 6, there's only one 6, so 6, the power stays the same. And 7, there's 2 there. 1, 2, so it's 7 squared, or 7 to the power of 2. And we are done. So we can see that we have written this question here in index form. We haven't worked it out, and you don't have to. That's all it's asking you to do. Now, before we start with examples, you need to make sure you understand what this title means. And in any topic, what do these keywords mean? Prime is just referring to prime numbers, okay? And we know what prime numbers are. That's all it's referring to. And factorisation, it's a big word, but all it's saying is prime numbers that are factors. So a keyword in there is factors, okay? So basically what we're doing is we're going to be getting numbers and writing them in a way where we can see their prime factors. Prime numbers that are factors of a number. And every number has prime numbers that are factors. So let's try an example. So this is a question from your textbook, and this is how the questions will look like. So write 14 as a product of prime factors. And that sounds confusing. Sometimes the question asks you to use a factor tree, okay? So what we want to do is get the 14, and you need some space on the bottom. Okay, if you know how to do this, you can do it yourself and then check your answer. But if you're not sure, watch this way. So I'll change my color. Now in this question, there are some keywords I want to outline. Product, we know product links to multiplication. So whenever you see product, you think of times, okay? Think of multiplication. So, and then as a product of prime factors. And we know what prime numbers are and we know what factors are. So in the end, we should see numbers that are being multiplied, and these numbers should be prime numbers. All right, so to start this this factor tree, 14, what is something times something to give you 14? Okay, don't do 1 and 14 because it won't change anything. So we know 1 and 14, yes, they're factors of 14, but that won't work. Maybe we can try 2 times 7. Does that give us 14? Yes, it does. Now, sometimes a factor tree, the multiplication is invisible, okay? So, but I like to write it in there. So you might see it like this, or some examples do have times in there. Now, this is a special one because we can pretty much stop here. So when doing factor trees, you always stop at the prime number. You can't keep going once you hit a prime number. 2 is a prime number and 7 is a prime number, okay? You can, if I did this, 2 times 1 and 7 times 1, is there a point in me doing that? No, there isn't. So we don't do that in our factor trees. Once you have reached a prime number, in this case 2 and 7, you stop. You cannot keep going. So this one was a pretty easy one. And then let's write it down in prime factor form. This is what prime factorization means. So we've got 2 times 7, and we know that 2 times 7 gives us 14, and 2 and 7 are prime numbers. And they're prime numbers that are factors of 14, and that's it. So that was a pretty easy one. Let's try another one. Okay, so I want you to try doing 42 first and have a go. So now, with this one, get our branches ready. That's why they're called factor trees. These lines are sort of like branches. And always start off, what is something times something to give you 42? And we can't go 42 times 1. Now, 42 is getting a bit large, but because it's even, I know that 2 times something will have to give me 42. And it has to be half of 42. So what is half of 42? Well, I know 2 times 21 will give me 42. Now you can see I like to keep my factor trees nice and neat, so I put my prime number 2 on this end. So when you know you have a prime number, put it on the first end if you want to. Now 21, it's an odd number, but we know it's not a prime number. So this one now has to keep on being broken down. What is something times something to give you 21? Think of your 3 timetables, and I know that 3 times 7 gives me 21. Now 3 is a prime number and 7 is a prime number. So now this factor tree is complete, okay? Every branch, okay, ends in a prime number. So we stop there. We can't keep going. Now, what I like to do is I circle my prime numbers or my prime factors so I don't forget any of them. And now I'm going to write them together down here. 2 times 3 times 7, okay? And do a check. Does 2 times 3 times 7 give us 42? Let's have a look. 2 times 3 is 6, and 6 times 7 is 42. So yes, it does. And if you had 6 times 7 up here, 6 times 7, instead of 2 times 21, you should have still gotten the same factors on the bottom, the prime factors. Now, there's nothing for us to simplify here, and we are done. Okay, let's try one more for this session. So have a go at doing this one first. So 150 is starting to become a large number, but that's fine. So we need to find something times something to give us 150. Yes, I can divide this by 2 because 150 is an even number. But I might try 10 times 15. Because I know 10 times 15 also gives me 150. Now I can see that 10 and 15, they are not prime numbers. So each one can now be broken down further. So each one gets its own branches. Now, what is something times something to give me 10? I know that 2 times 5 gives me 10. So write that down. And I can see that 2 and 5 are prime numbers. So my tree stops here. On this side, I've got 15. What is something times something to give me 15? I know that 3 times 5 is 15, so I'll just write that down. And my tree ends here because I can see 2, 5, 3, and 5. They are all prime numbers. So I'll circle them. Okay, this one worked out nice and neatly, all on one level. And now I have to simplify my prime factors. So I'm going to write them out. I've got 2 times 5 times 3 times 5. And now I'm going to simplify what I can. And you can arrange them in order as well, from smallest to largest in ascending order. So I can see I have 2 5s that can be simplified. So I'm going to go 2 times 3. There's only one of those. And now the 5, they're all my bases written down. And now I've got 2 5, so it's going to be 5 to the power of 2. And that's it, we're finished. So we have shown the prime factors of 150. And of course, do your check. Does 2 times 3 times 5 squared, or 5 times 5, give us 150? Well, 2 times 5 is 10. 10 times 3 is 30. And 30 times 5 is 150. Okay, so keep practicing these questions by doing the exercises in your textbook. Thank you.